In this video, we will use factoring in order to solve limits. If you evaluate this limit using your calculator, you will get 0 divided by 0. Your calculator isn't wrong, it's just that there's a hidden simplification which we'll explore in this video. But first off, what actually is 0 divided by 0? Well, if we think back, this simply just means what number times 0 is equal to 0. Well, any number times 0 equals 0. So it could be 2, or 3, or 17.5, even 0, or even a million. We simply just don't know. This is why we call this an indeterminate form, and this shows up all the time throughout calculus. So let's explore how we could use factoring in order to evaluate this limit. So I have x squared minus 4. So I just need to think about what two numbers multiply up to -4 and add up to 0. So that would be -2 and +2. So now I'm going to rewrite the limit statement as the limit as x approaches 2 of x minus 2 times x plus 2, all divided by x minus 2. Well, I notice I have an x minus 2 in the numerator and an x minus 2 in the denominator. So those two are going to cancel out. And I am now left with the limit as x approaches 2 of x plus 2. Well, now I can drop the limit statement and use direct substitution, plugging in 2 for x. So I get that 2 plus 2 is equal to 4. So this means that the limit as x approaches 2, x squared minus 4, divided by x minus 2 is equal to 4. So let's take a look at another example. Let's say I have the limit as x approaches 3 of x squared minus 9 divided by x minus 3. Well, I have a similar situation. I need to ask myself what two numbers multiply up to -9 but add up to 0. So I know that's going to be +3 and -3. So I'll do x plus 3 times x minus 3. So I'm going to rewrite the limit statement as the limit as x approaches 3 of x minus 3 times x plus 3, all divided by x minus 3. So I know that x minus 3 on the numerator and x minus 3 in the denominator cancel out. And now I'm left with the limit as x approaches 3 of x plus 3. So now I can drop the limit statement and use direct substitution, and I get that 3 plus 3 is equal to 6. So this means that the limit as x approaches 3 of x squared minus 9 divided by x minus 3 is equal to 6. Now let's take a look at a more complicated example, which requires us to factor both the numerator and the denominator. So we are given the limit as x approaches 6 of x squared minus 2x minus 24 divided by x squared plus 2x minus 48. So let's first start by factoring the numerator. So I know that I need to figure out what two numbers multiply up to -24 and add up to -2. So I know that 6 and 4 multiply up to -24. Now I know that -6 plus 4 equals -2. So -6 and +4 are going to be my factors. Now let's factor the denominator. So I have x squared plus 2x minus 48. So I know that two numbers that multiply up to -48. So two numbers that multiply up to +48 are going to be 6 and 8. Now I also have to add up to +2. So I can do a -6 plus 8. So I know that -6 plus 8 is equal to +2. So those two are going to be my factors. So now I just replace the limit with the limit as x approaches 6 of x minus 6 times x plus 4 divided by x minus 6 times x plus 8. So these two are going to cancel, and I am left with the limit as x approaches 6 of x plus 4 divided by x plus 8. So now I'm able to drop my limit statement and use direct substitution. So I do 6 plus 4, which is equal to 10, divided by 6 plus 8, which is equal to 14. 10 divided by 14 can be simplified to 5 over 7. And that is what the limit is equal to. So now let's recap what we've learned. So when using factoring to evaluate limits, make sure to factor both the numerator and the denominator. Next, see what cancels out. Then you can use direct substitution to evaluate the limit. Remember, don't drop your limit statement until you are able to use direct substitution. Thank you, and I hope that was helpful.